So 14.3, I'm going to start off about dilations. This again is something that you recognize, because in Math 8, this is something that you did. I remember going through some of these in Chapter 2 of that book, actually, itself. I'm going to make one change of something. Cross out center of dilation and write scale factor. Because this diagram illustrates the center of dilation itself, so I actually meant to put scale factor in there. Okay, so a dilation is simply an enlargement or a reduction of something. So we need to just write enlargement or reduction. So we're enlarging a figure or reducing a figure. Pre-image is the term for the original figure. And make sure you remember the difference between that pre, meaning first, so that will help you with it. Therefore, the image is actually the second one, or the new image. After we have done an enlargement or a reduction, the new image is called the image. So pre-image and image, I don't know why they can't learn, but it's almost too simple, but still. The scale factor is going to be the multiplier to make the pre-image into the image. So it's a number that you multiply. And they often use k in these problems, sort of like y equals kx, so it's sort of like you've done before. But I don't even really use that myself much, so I'll just tell you the book says that. And so it's sort of like the slope too. So think of it as slope or as the variation number in a direct variation. But in this case, we're going to focus on using the scale factor as a multiplying number. So let's take a look down here. This is triangle A and this is triangle B. And I drew these lines here to show that there's a particular point that called the center of dilation. That's the one that sort of like if you have a flashlight, and you know some people, you get a flashlight, a light, and they can make little figures against a wall based on that. Well, that's really what they're doing. You know, the flashlight is a center of dilation, and it's dilating someone's movements or something you're holding there and making it much larger up on the wall. Well, that's what's happening here. So in this case, if we were starting with A, the center of dilation goes up here and shows that B is that this would be the pre-image and this would be the image. Or the other way around, if this one is the one we're starting with and we're reducing it, there's the pre-image and there's the image. So here's what we're going to do with this. Okay, so I'm going to put some numbers here and we're going to work. Oh, do we want some numbers here? Yes, I do. This side length here, I'm going to say is 4 millimeters. This side length here is going to be 12 millimeters. And then we're going to do a couple of questions about it. Easy question and hard question. Actually, easy question and almost as easy a question, not really hard. First one is, if we're going from A to B, you have to be able to say if it's an enlargement or reduction. It's pretty easy, you're enlarging it. So it's an enlargement. And if you're going from B to A, you're clearly reducing it, so you actually have to say it's a reduction. So that's more a matter of just paying attention to which triangle you're doing. So the next thing I want to look at is the scale factor, and this is where it gets a little tricky, only because people just sometimes just mix up which way it is. Okay? So if I'm going from A to B, I'm doing 4 times 3 to make 12. Pretty obvious. So 4 times x equals 12. So that means x equals 3. It's not really x. What I have to say is 3 is the scale factor. You don't even really have to do this kind of thing. It's just an easy way to show the mathematical, the algebra to it. But it's what you need to multiply this to get to this. Over here, I'm going to do the scale factor for this one. And it's very tempting for people to look at this and say, oh, okay, I have 12, I'm trying to get to 4, so I'm going to divide by 3. 12 divided by 3 is indeed 4. Okay? So they say 3 again. They say the scale factor is 3. You're dividing, not multiplying. I said multiplier on purpose. I said multiplier up here on purpose. I said multiplier down here 3 or 4 times on purpose. If you do 12 times 3, you get 36, not 4. So you have to do it as a fraction. You have to do the reciprocal of that. It's 12 times 1/3. So the scale factor, the multiplier, is 1/3. Because you're doing like 12 times x equals 4. That's why doing this little thing would be the way of making sure you get it right. When you divide by 12, you get 4/12, which is 1/3, and that's your scale factor. Be careful about that. Okay? Don't pick a scale factor, or don't do a division in this case. That's really the only tough thing on this. There really isn't anything hard about this, except remember you're not dividing, you're multiplying, so you have to sometimes use a fraction. Almost always when you're doing a reduction, it's almost always a fraction or a decimal. Okay? This one, don't make it a decimal, because if you round this, you're not going to get the exact number here, and you've got to get exactly 4. So if I did 0.333, and I multiplied that to 12, I would get, 4.00001 or something like that. That's not 4. So don't use a decimal. Unless it was something different, like, if that was 16, then I'd multiply by 1/4. You can make that 0.25 because you're going to get the same thing. That's an ending decimal, so that's okay. So sometimes it's okay, sometimes it's not. The thing is whether or not you have to round it. If you have to round it or approximate it, don't do it. Keep it as a fraction. We only use a decimal if it ends the decimal. Okay, that's page 1. Let's look at the page 2-1 here. And I have a nice little graph. I finally figured out on the computer how to do a wider graph so we can still see and work with. So what I'd like to do here is put a couple of triangles here. So follow along with me. I'll make this a little larger. Oops. Up here. So I want to go here to 3 and here to 2. So on the x-axis go to 2 and the y-axis go to 3, and we'll make a triangle here. And then I also want to go up to 9, 4, 5, 6, 7, 8, 9, and out to 6, 2, 4, 6. You are welcome to use rulers if you want. Please excuse me for not being able to make straight lines well, but you don't have to anyway. Get the idea. Do these. We have 2 triangles, okay? And in fact, let's do a couple of letters here. So this point at 0, 3 is A. This point at 2, 0 is B. I'm going to use C as the point of origin, 0, 0. So A, B, C. And then we'll go up here to 9 and we'll do D. And we'll go over here to 6 and we'll call that one E. We have to prove that these 2 triangles are similar. So ABC is similar to DEF. You look at it and say, common sense says it is, and that's nice, but I need proof. So we need to prove it. That means we either need to do side, 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 or we need to do side, angle, side, or we need to do angle, angle. Angle, angle, well, already both of them have a 90-degree angle, but measuring this angle and matching it to that angle looks a little more difficult than what I think I could do right now. And the same thing with this one and this one. I might be able to do it if I want to prove parallel lines here, and I could maybe do that, because if you think about it, you have parallel lines. But we might also be able to do it in other ways. When 2 years, you're going to learn enough of trigonometry to be able to get this angle by using the 3 and the 2 here. And so there's another way you'll be able to do it. But I'm not quite prepared to spend a couple of weeks teaching you all the trig stuff before that. Then you could do it. So we'll wait in 2 years, and then you can do it that way. Right? What we can do is use the fact that this is an angle, and we have sides here. So I'm guessing side angle side might work. And also the side lengths might work. So what I'm going to do here is I'm going to do 2 ways. I'm going to spend some space over here, and I'm going to see if side angle side works. So let's see if we can match up sides and match up an angle. And then I'll use the space over here to do side, side, side. Got a lot of room on here. So The distance for this one is 3, and the distance for this one is 9. So A to C, and let's actually do, let's see, AC over DC is 3 over 9, which is 1 over 3. Now, I have the S. Angles, I can say that angle C is congruent to angle C. So I have the A part. Yes, that seems like real common sense. You still actually have to write it. I have a side, I have an angle. And even though on the original problem that I did a few pages ago, I put this at the bottom of the 2 for the side angle side, it really should be in the middle. I won't take points off if you don't do that, but I think I want you to get into a good habit of that. I'm going to start making sure I do that too. And the other side, so I have side and angle. I have to do the side on the other side of that angle. And so it looked like I have 2 and I have 6. So B to C over E to C is 2 over 6, and that is 1/3. So these sides are in proportion to each other, and the angle in between them is the same amount. That's side, angle, side. So now I can say the triangle CBA is congruent to triangle CED by SAS. So there's my similarity statement, and here is the proof of the similarity statement. Side, angle, side. And we could say an S, an A, and an S. I like that. Not required, but it's nice to do that. But I also can do it by side, 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 and I want to show this because some people like the distance part of it. We can actually take these and find the distances. Okay? And I want to do that also just to review with you about distance formula, or the fact that when you have a coordinate point, you can just use the Pythagorean theorem to find distances. So what we're going to do here, as a reminder, the distance formula is d equals the square root of 1x minus the other x, x2 minus x1, plus, and we square it, y2 minus y1, and we square that. So you can calculate that using 6092003. We calculate that. I find it a lot easier just to use a squared plus b squared equals c squared. So for AB, the length of AB, if you think about it, this distance here, that distance squared, that distance is equal to 3 squared plus 2 squared. So a squared plus b squared equals c squared. So I'm using d for distance. It doesn't really matter what letter. Actually, I guess I'll do AB and square that. So that means AB squared is 9 plus, that's 9, that's 4, that's 13. Take the square root, and the length of AB is the square root of 13. It's not a nice number, but it doesn't really matter. Because what I want to find out is that, if I put that in over, like this, if I put that amount over this amount, will it come to 1 over 3? If it comes to 1 over 3, that means that these sides are in proportion. So I'm going to do it with this one. The length DE, if I take the length DE and I square it, that should be equal to this length squared, A squared, or B squared, doesn't matter which one, that was larger, but still. 9 squared plus 6 squared. So DE squared, okay. So if that's 9, that's 81. And 6 squared, let's see, 6 squared is 36. DE squared, so that's what, 117. I have a 117 here, let's take the square root. So the length of DE is the square root of 117. So if I want to see, I've already proven that this side and this side, that this to this is 3 over 1 or 1/3. This to this would be 3 over 1. Let's see about this one. Since I kept it to 1/3, so let's keep the smaller one on it. So AB over DE is square root of 13 over the square root of 117. There's a reason why I tell you you can use calculators. I'm certainly not going to do those in my head. I'm pretty good with my numbers, but that's a little further than I can go. on here. Square root of 13 comes to that amount. I'm going to divide that by the square root of 117. That looks like it's supposed to be 1/3. Okay? So 0.3, all that repeating, you know, I don't want to round it anywhere, so I need to leave it in the fraction form, so that is indeed 1/3. So if I did this method, I could then say side, 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 that triangle ABC is congruent to triangle ABC, so that's DEC by side, side, side. If you want to use side by side, you must do that in this kind of a problem. If you don't want to do that, and there's enough info for you to do side angle side, you can do side angle side. Just make sure that you are ready. Okay. That's it for 14.3.